Hello everyone, welcome to the video on software testing. What's in it for you are, first, what is software testing? Next, the different types of software testing, and then software testing techniques. Once this is done, we will understand how software testing is performed at different levels. Moving on, we will discuss some best practices for software testing. Next up, benefits of software testing. Finally, let's look at some popular software testing tools. Without further ado, let's get started. What is software testing? Software testing is a method to check whether the actual software product matches expected requirements and to ensure that software product is defect-free. The goal of software testing is to identify any defects, gaps, or missing requirements compared to the actual requirements. So software testing is act of checking whether software satisfies expectations. It provides objective, independent information about the quality of the software. It assesses the risk of software failure to the user or sponsor. Software testing can determine the correctness of software for specific scenarios. However, it cannot guarantee correctness for all possible scenarios. Also, it is impossible to find all bugs through software testing. Software testing is divided into two processes, which are verification and validation. Verification process makes sure that we build the software correctly, whereas validation ensures the software meets the user needs. Now let's understand them. First, verification. Verification checks if you are building the software right according to its specifications. So it ensures correct development according to specifications. It checks internal aspects like code and design. It verifies work products meet quality standards. The work products are requirements documents, design specifications, and code. So verification helps in improving the development process by identifying inconsistencies, ambiguities, and errors in documentation and code. Examples of verification activities include code reviews and unit test. Next, validation. Validation checks if you are building the right software that meets user needs and expectations. So it ensures software meets user needs. It focuses on user satisfaction. It verifies whether the software functions correctly in its environment. Validation makes sure the software is ready and suitable for release. Examples of validation activities include user acceptance testing and beta testing. So what is the importance of software testing? Early defect identification. Testing spots problems earlier, so it stops them getting worse later on. Next up, better quality. Testing ensures that the software meets the specified requirements and functions as intended. By identifying and fixing defects, testing helps in improving the overall quality of the software, which leads to more reliable and robust product. And then happy customers. Quality software that is free from defects and perform as expected leads to higher customer satisfaction. Next up, scalability. Testing ensures that the software can handle growth without breaking. And finally, time and cost savings. Finding and fixing issues earlier saves time and money in long run. So software testing is essential for ensuring the reliability, functionality, and performance of software systems. Let's discuss some incidents that emphasize the crucial need for thorough software testing and quality assurance. In 1985, Canada's Therac-25 radiation therapy malfunctioned due to a software bug and resulted in lethal radiation doses to patients, leaving 3 injured and 3 people dead. In 1994, China Airlines Airbus A300 crashed due to a software bug, killing 264 people. In 1996, a software bug mistakenly credited $920 million to the bank accounts of 823 customers in the United States. In 1999, a software bug caused the failure of military satellite launch, which worth $1.2 billion. In 2015, a software bug made the F-35 fighter plane unable to detect targets correctly. Again in 2015, the Bloomberg terminal crash disrupted financial markets and government operations. Due to a software failure in its POS system, Starbucks had to close over 60% of its outlets in the US and Canada. And Nissan had to recall 1 million cars from the market because of a software failure in the airbag sensors. So from these incidents, it is clear that the software testing is indispensable. Now let's move on to the types of software testing. There are various types of software testing, and each serve a specific purpose in evaluating different aspects of software's functionality, performance, and usability. These types can be broadly categorized into two main groups, which are functional testing and non-functional testing. Apart from this, we have maintenance testing, manual testing, and automation testing. Functional testing focuses on verifying the software's functionality against its specified requirements. Here, the individual functions or features of software application are tested, which make sure they behave according to the specifications and meet the functional requirements. This type of testing focuses on what software does rather than how it does it. Functional testing typically involves requirement analysis, test planning, test case development, test execution, defect reporting, and regression testing. Functional testing can take various forms like unit testing, integration testing, system testing, and acceptance testing. Functional testing is essential for ensuring the quality and reliability of software applications before they are released to users. It helps to identify the defects early in the development process, which helps in reducing the risk of issues in production and ultimately improve the user experience. Non-functional testing evaluates the software's performance, security, usability, and other non-functional aspects. So here it involves testing the software's performance, scalability, reliability, and other characteristics that are not directly related to its functionality. We know that functional testing focuses on what system does, whereas non-functional testing evaluates the performance of a system under different conditions, such as high loads, varying network speeds, or with limited resources. Performance testing, reliability testing, usability testing, security testing, scalability testing, compatibility testing are some common types of non-functional testing. So non-functional testing is essential for ensuring the overall quality, performance, and reliability of a software system. Maintenance testing is also known as regression testing. Maintenance testing involves updating software to meet changing customer needs, fix issues, or enhance functionality. It includes making adjustments, modifications, or updates to the software code or features. Regression testing is a key part of maintenance testing. It verifies the recent changes made to the software haven't negatively impacted the previously working parts. So maintenance testing helps in preventing new defects or issues which arise due to the changes in software. It ensures that the software remains stable and reliable even after the modifications have been made. So by conducting maintenance testing, software system can continue to meet the user needs and expectations over time. Manual testing relies on human testers to execute test cases without automation tools. Here testers navigate to the software manually and they perform actions such as clicking buttons, entering data, and navigating menus. Here the tester takes over the role of an end user and tests the software to identify any unexpected behavior or bug. So the primary goal is to uncover bugs or defects that may affect the user experience or functionality of the software. Testers use test plans, test cases, or test scenarios to evaluate the software to ensure its quality and reliability. Unit testing, integration testing, system testing, and user acceptance testing are different stages for manual testing. Manual testing includes exploratory testing, where testers explore the software freely without strict predefined steps. So it is a flexible method which allows discovering unexpected problems. Automation testing is also known as test automation. Here tester creates scripts to automate testing procedures. These scripts are then executed by specific software. So in automation testing, we use software tools to execute the test and compare the actual outcomes with predicted outcomes. Testers write scripts or use automation tools to automate the testing process. It can be used for various types of testing, including functional, regression, performance, and load testing. That is, automation testing tests the application from a load, performance, and stress point of view. Load testing checks how well the app handles many users at once. Performance testing checks how fast and stable the system is and if it can handle different loads. Stress testing puts the system through tough situations to see if it can handle them without crashing. So the main benefits of automation testing is it saves time and effort, reduces human error, and allows for testing to be performed at any time of the day. Now let's discuss some common software testing techniques. There are 3 common software testing techniques, which are black box testing, white box testing, and gray box testing. Black box testing focuses on system input and output without considering the internal workings. So black box testing concentrates on the external behavior of the system, which examines how it responds to various inputs without delving into its internal workings. Testers performing the black box testing typically do not have access to the internal code or structure of the system. They operate based on the specifications, requirements, or user stories. The primary objective of this testing is to check if the system behaves correctly with different inputs without the knowledge of internal working. Black box testing can be applied to various types of systems, which includes software, hardware, and firmware. Equivalence partitioning, boundary value analysis, and use case testing are common examples of black box testing techniques. These techniques are used to design test cases and validate system behavior. Equivalence partitioning groups similar inputs together and test one input from each group. Boundary value analysis determines the upper and lower limits of input ranges and create test cases for values at just below and just above these boundaries. Use case testing look at how users will use the system and test each user scenario. White box testing focuses on internal working of the system. So it examines and evaluates the internal logic, structure, and implementation of software system. Here the tester has full knowledge of internal code and structure. The main objective of white box testing is to find the defects within the code base, also ensuring that the code is well structured, efficient, and follows coding standards and best practices. White box testing is used for testing individual components like functions, modules, and classes. Statement coverage, decision coverage, and conditional coverage are examples of white box testing. Statement coverage ensures each statement in the code is executed. Decision coverage ensures each decision point in the code is evaluated to true and false. Condition coverage ensures each condition in a decision statement is evaluated to true and false. So in black box testing, the internal working of an application are not required. It is also known as closed box or data-driven testing. It is normally done by testers and developers. This testing can only be done by a trial and error method. To do white box testing, the knowledge of internal working is must, and it is normally done by testers and developers. It is also known as clear box or structural testing. With this type of testing, data domains and internal boundaries can be better tested. So white box plays a crucial role in verifying the internal quality and correctness of the software system, whereas black box testing ensures the comprehensive test coverage and overall software reliability. Gray box testing merges black box and white box testing. Here the tester will have some understanding of system's internal workings. Gray box testing verifies the system's behavior and assesses its internal structure. Gray box testing is frequently used in software testing, particularly at integration level. State transition testing, decision table based testing are examples of gray box testing. The state transition testing examines how a system moves from one state to another in response to inputs or events. Decision table based testing uses tables to show how different combinations of input lead to specific outputs, which helps testers to identify the test scenarios. Now let's understand the levels of software testing. And these are the primary levels of software testing, which are unit testing, integration testing, system testing, and acceptance testing. Unit testing is first level of software testing. It focuses on testing individual units or components of a software or a system, such as functions, methods, or classes, to ensure they work correctly in isolation. Unit testing is performed by developers, typically during the development process. The purpose of unit testing is to validate that each unit of software performs as designed. Unit tests are automated, which means they can be run automatically without requiring manual intervention. These automated tests are run often, usually every time there is a change made to the code. And this is known as continuous integration and continuous deployment. There are some testing frameworks which are commonly used for unit testing, which are JUnit, NUnit, PyTest, and Jest. JUnit is widely used for unit testing in Java projects. JUnit provides a framework for writing and running tests to validate individual units of code. NUnit is similar to JUnit, but it is tailored for .NET languages like C# and VB.NET. NUnit is used for writing unit tests in .NET ecosystem. PyTest is popular choice for unit testing in Python. PyTest offers a simple syntax and powerful features for writing and running tests efficiently. Jest is specifically designed for JavaScript, particularly for testing JavaScript code. Jest is commonly used for unit testing in Node.js applications and React projects. And the key benefits of unit testing and automation are listed here. Unit tests find the bugs earlier, so it helps developers to fix issues before they become major problems. Thereby, it reduces introducing new bugs or regressions. Next, it improves code quality and reliability, and then it simplifies integration. Unit tests make it easy to integrate new code changes with existing functionalities, with reducing conflicts and errors. Integration testing is second level of software testing. It focuses on testing how various units or components of software interact with each other. The main goal of integration testing is to verify that the integrated components of the software functions correctly together as a whole. Integration testing can be performed at various levels, like module testing, component testing, and system testing. Module testing tests individual modules. Component testing tests group of modules. System testing tests the entire system. During integration testing, individual units of codes are combined and tested together as a group. By testing how different units interact with each other, integration testing can expose faults in the interaction between integrated units. Automated integration testing increases efficiency. That is, automated integration test can be executed faster and more consistently than manual test, which will reduce the time and effort required for testing. Next, it improves accuracy. Automated tests reduce the risk of human error, so it leads to more accurate and reliable test results. Moving further, it provides faster feedback. That is, automated tests can provide faster feedback on code changes, which allow developers to catch and fix issues early in the development cycle. There are several tools commonly used for automated integration testing, like Selenium, Cucumber, and Postman. Selenium is an open source tool for automating web browsers, which allow you to test web applications across multiple platforms and browsers. Cucumber is a tool for behavior-driven development, which allow you to write tests in a natural language format that can be easily understood by non-technical stakeholders. Postman is a tool for API testing, which allow you to test RESTful APIs and automate the testing process. And here are the benefits of automated integration testing. Increased speed and efficiency. So automation helps to increase the speed and efficiency of testing process, which reduces the time to market and manual effort required for testing. Next, improved software reliability. Automation helps to identify defects early in development process, which will lead to better software quality and reliability. And next, better regression testing. Automated integration testing provides comprehensive coverage of integrated system, which improves regression testing and ensures that the changes do not impact the existing functionality. System testing is the third level of software testing. System testing involves testing the entire system end to end to ensure it meets user requirements. So the goal is to ensure the system works correctly as a whole and meets both functional and non-functional requirements. System testing is typically performed by a dedicated testing team, and it involves testing the complete integrated system or software. This level of testing helps to identify any defects or issues that may have been missed during the unit testing and integration testing. The primary purpose of system testing is to evaluate the system's compliance with the specified requirements. Automated system testing is an effective way to improve the effectiveness and coverage of testing process. And it is done using automation tools and scripts to automate the execution of test cases in software development and quality assurance processes. Automated system testing verifies the functionality, performance, and reliability of entire system from end to end without requiring manual intervention. JMeter, Test Complete, and Appium are some of the tools for automated system testing. JMeter is an open source tool for performance and load testing. Test Complete is a commercial tool for automated testing of desktop, mobile, and web applications. Appium is an open source tool for automated testing of mobile applications. And here are the benefits of system testing. First, it ensures end-to-end functionality. System testing ensures that the entire system works as expected, thereby covering all the critical business scenarios. It verifies that the system integrates correctly with all other components, services, and third-party APIs, which provide a comprehensive view of system's functionality. Next, it enhances user experience. That is, system testing helps to identify and fix issues that can impact the user experience. And next, it identifies integration issues. System testing helps to identify integration issues between different components, services, or systems. By testing the system as a whole, it may find issues that are not caught by unit testing or integration testing. Acceptance testing is final level of software testing. It ensures that the system meets the user acceptance criteria and it is ready for deployment. Acceptance testing focuses on validating the system's functionality, usability, and performance concerning user expectations and real-world scenarios. This level of testing is typically performed by end users or their representatives, and they will make sure the system is ready for deployment and meets the user needs and expectations. So the primary objective is to validate compliance with business requirements and evaluate system acceptability. Automated acceptance testing focuses on automating the execution of test cases and compare the results against expected outcomes. And this method is very much useful when dealing with large complex systems or applications that require frequent testing. And these are the benefits of acceptance testing. Improved system quality. So in this level of testing, the system is thoroughly tested, which leads to higher quality system that meets the required standards and user expectations. And next, faster feedback. Automation acceptance testing provides faster feedback on system performance and compliance with business requirements. So this enables the development teams to identify and resolve defects quickly, and thus it reduces the overall testing time and effort. Now, what are the best practices for software testing? Now let's understand the key components of effective software testing planning. First, a formal testing plan. A formal testing plan is a structured document which outlines the testing objectives, scope, approach, resources, and schedule. Formal testing plan will serve as a roadmap for testing activities throughout the project lifecycle. Next, integration in development stage. Testing activities are integrated into development process from the beginning. So integrating testing with development ensures that the potential issues are identified and addressed early in the development process. And it is an iterative approach, which provides benefits like early bug detection, continuous feedback loop, and improved collaboration. Next up, test-oriented development practices. So methods like test-driven development and behavior-driven development are development methodologies that emphasize writing test before writing code. So both TDD and BDD promotes a test-first approach, which can lead to more robust, maintainable, and well-tested code. And then adequate reporting of test results. We need to document and communicate test observations, progress, and outcomes effectively. So it provides stakeholders with visibility into the testing process and results. Next, comprehensive testing coverage. Make sure all the critical aspects of software are tested, including functional, non-functional, and edge cases. And then test on real devices. Testing on real device ensures the reliability and performance of software in real-world scenarios, so that we can identify the platform-specific issues and hardware-dependent features, also UI and UX issues. Next, testing metrics practice. Quantitative measures are used for assessing and enhancing the effectiveness and efficiency of testing efforts. Quantitative measures use numbers to see how well the test works and figure out how to make them better. Some common quantitative measures are testing coverage, defect density, defect detection rate, test execution time, test automation coverage, test case effectiveness. And next, distributing tasks according to skills. Assigning testing tasks based on team members' skill ensures that the tasks are completed efficiently and effectively. And then testing one feature per case. Testing one feature per case simplifies the testing and debugging process, which make it easier to identify and fix issues by isolating the functionality being tested. And finally, provide version rollback option. So implementing a version rollback option provides a safety net against unintended consequences of software updates. Thereby, it ensures stability by enabling reverting to previous version in case of critical issues or regressions. Now let's understand the benefits of software testing. The benefits of software testing are listed here. First, early bug detection. Testing helps us to identify and fix bugs early in the development process so that we can save time and money in long run. Next, improved functionality. Testing ensures that the software functions as intended and meets the user expectation. Then increased user satisfaction. By identifying and rectifying issues before the software is released, testing helps us to deliver a higher quality product. This in turn enhances user experience and satisfaction with the software. Next, reduced risk. Testing helps to reduce the risk associated with software failures such as financial losses, damage to reputation, and legal liabilities. Next up, cost effective. So investing in testing can save cost in long run by reducing the need for rework, bug fixing, and customer support. And then we have better decision making. Testing tells stakeholders if the software is good to go or not. And finally, regulatory compliance. Testing ensures that the software meets all the necessary regulations and standards, so it reduces the risk of facing legal penalties. Now let's move on and understand some software testing tools. First, Jira tool. It is widely used for issue tracking and project management. It helps the team in planning, tracking, and managing their work. Also, it provides features like creating and assigning issues, tracking progress, and reporting. Also, it supports agile methodologies and provides features like Scrum and Kanban boards. It can be integrated with other tools like Confluence, Bitbucket, and GitHub. Selenium is an open source tool for automating web browsers. It facilitates the creation of automated tests for web applications. It supports multiple programming languages like Java, Python, Ruby, and C#. It provides features like recording and playing back test reporting, and integration with other tools. It supports multiple browsers like Chrome, Firefox, Safari, and Edge. Appium is an open source tool for automating mobile web and hybrid applications on iOS and Android platforms. It provides a uniform API for automating tests across different platforms. It supports multiple programming languages like Java, Python, Ruby, and C#. It provides features like recording and playing back test reporting, and integration with other tools. It supports multiple mobile devices and emulators. Next, Load Runner. It is developed by Micro Focus. It is an industry standard performance testing tool. It supports protocols like HTTP, HTTPS, SOAP, REST, and more. Next, Apache JMeter. It is an open source performance testing tool which is designed for load testing and measuring performance with focus on web applications. It is a platform independent and can run on any environment that accepts Java Virtual Machine. It is capable of simulating heavy loads against a server, network, or application. Test Complete is an automated testing tool that supports function, regression, and load testing. It can be done on web, mobile, and desktop platforms. And next, Visual Studio Test Professional. It is a testing tool from Microsoft. It supports various testing types including unit testing, manual testing, and automated testing. And here are two popular API testing tools. Postman tool simplifies API creation, testing, and documentation. It is user-friendly interface. SOAP UI is open source API testing tool. It supports SOAP and REST APIs. It enables creation, automation, and execution of tests. Next, Jenkins is an open source automation server. It supports continuous integration and continuous delivery for software projects. Jenkins automates the building, testing, and deployment of software. And next, Cucumber. It is a popular testing tool that supports behavior-driven development. It enables teams to write tests in human-readable format, which makes it easier for stakeholders to understand the intended functionality and expected behavior of the system. Cucumber uses a language called Gherkin to define test scenarios, which are then executed by Cucumber tool. And next we have Robot Framework. It is an open source test automation framework designed for acceptance testing and acceptance test driven development. It follows a keyword driven approach which allows users to create test cases using tables. And that's all for this session. Thank you so much.